Thank you, Tone. Good morning, everybody. So, as Tone said yesterday, we have reviewed a little bit the history of recent changes to Bitcoin, what was controversial, what was not, what changes we strive to activate and which changes we strive to not activate, like the 2x attack. And now we wanted to do something symmetrical about the near future and the possible changes that you will see proposed or maybe rejected in the next month. So we will try to stay a little bit in the near future. We will not go full Ethereum about crazy promises about 2080. We will try to stay a little bit on what will realistically potentially happen in the next months or let's say kind of before the next Understanding Bitcoin conference, if possible. So you can see here people you already know. Adam is now here in the function of a panelist, but he is also, of course, one of the main organizers of the conference. And then you already listened yesterday, Lawrence, talking about wallets and keys. And then Christian was the star of Lightning yesterday in the late evening. Right now, I will ask them as a first round to tell us a little bit your general vision about the next thing that Bitcoin should or could possibly change for the better, especially focusing on protocol level changes. What could be controversial? What could be smooth? When do you expect, hypothetically, the activation? If you want, you can also mention some kind of change that maybe they will try to push and is not really wanted. So, Adam, let's start with you.
One of the big things that's been worked on for some months now is Schnorr signatures, and a clever invention that is being put together with that, which is Taproot. And the advantages of this technology are smaller signatures, particularly for multi-signatures. So 2 of 2 signature becomes the same size as a 1 signature. 2 of 3 maybe is not so much smaller, but still smaller. And the other advantage is slightly better privacy and fungibility. So many Bitcoins come with a small contract, a very small program that's attached to the coin, which says how the owner can spend it. And typically it's organized as an if statement. So there's the normal case. If you use green address as an example, it has a 2 of 2 signature. And if something goes wrong, there's another or, or there's the emergency case where you wait some time, so there's a time lock and another signature. And many things are organized like this, including Lightning channel establishments. And so what Taproot gives you is the ability to hide the second or statement. And because of the Schnorr part, 2 of 2 signatures look like single signatures. So basically it will harmonize all of what you see on chain. So you won't be able to tell the difference between a green address transaction, a single signature transaction, a samurai transaction, a Lightning channel establishment. And it's only if somebody has to close a channel in a hostile way or exercise one of the emergency recovery procedures if they've forgotten their 2-factor that you see more details. So as the 99% case is that you don't use the rare emergency access, this should be quite nice for reducing fingerprinting of wallets so that people can't look at the chain and guess which type of wallet created that or tell whether that is a wallet transaction for on-chain transaction or a Lightning channel setup. And so as to when this is coming, I think it's still ongoing work because there was one draft published, which was the format and crypto specification for Schnorr signatures. And there has to be another BIP which will describe a proposed format for an opcode to add a new signature type for Schnorr and Taproot. So my guess would be like very late this year, probably next year, but you would have to talk with the developers working on it. And there are a number of people working on it. Peter Willer, Gregory Maxwell, Johnson Lau, and probably other people. I'm not directly involved in it myself, other than being very pleased and interested to see this improved technology become used. And I think personally that it's very uncontroversial. It's just a technical improvement. It's not interrelated with scaling. In a sense, there's no block size or weighting difference for these transactions. So I'm hoping that it will go smoothly, and we'll see that. And the other thing that would be good is finally some of the wallets and libraries that have been slow to adopt SegWit are starting to adopt it. And Schnorr will be another format change, so another type of signature, So I think if people are sort of coming to expect that new formats get introduced and you upgrade things, we're already seeing now some of the very latest signature types in services. Some people are pushing ahead, so that's good.
So before moving to Lawrence, a funny story. We discussed a little bit with Lawrence, and he was especially eager to talk to you about Schnorr signature. So now that Adam stole your...
Yeah, I'm going to talk about C-lining now. I'm going to steal Christian Decker's topic. No. So, yes, I wanted to talk about what Adam just said, so thank you, Adam. And I agree that the primary achievement of Schnorr is privacy, in my view. But the other side of the coin is that it's also cheaper, it's more efficient. So, I mean, you can fit more transaction in a block. It means that your very complicated multi-sig transaction can be as efficient as a single-sig transaction. And I think that good privacy goes hand in hand with cheaper and more scaling. So fitting more transaction in a block, or like lining, it's a good way to scale and also improves the privacy, because once you open a channel, you don't see how much traffic. Oh, so I am stealing.
You could say how Green Address might use it.
Right. So we plan to use Schnorr and Taproot as soon as possible. The idea would be that instead of having CDSA 2 of 2 multi-signature as we have today, we would have Schnorr 2 of 2 with the CSV, or I think I need to do a step back to explain a few things. So today's green address model is there's a multi-signature with 2 keys, and there's a out-of-band message that you receive every time you either send or receive Bitcoins, and that allows you to recover just in case the server keys is not available. We plan to move very soon to something called check sequence verify, that instead of forcing you to receive something out of band, like by email, establish this condition on chain, so that it's atomic. You never have to wait to receive something in order to recover. It's automatically recoverable the moment you receive something. So it's in a way more trustless. And once we move to Schnorr, you can have something like that with Taproot. So as Adam said, it will look like one single signature when it comes to on-chain. The signatures are pretty much summed together of the 2 keys. And then there's another condition that in the Bitcoin script, so the thing that you reveal when you want to spend the transaction, that allows you to do the independent recovery, so with a different condition. And you can have pretty much an infinite set of conditions, I'd imagine. I don't know if there's a limit of how many conditions you can have. But you can have a condition where after 1 year, you can have, let's say you have a big company, and on a normal condition, you need 2, C-level directors to consign transactions before they're effective. But let's say something happens to one of them, or they're not available, then maybe the majority of the board of directors is enough to take control of the funds. And you could see something like that used in a business setting, but you could also see that happening in a family setting. So maybe I want to have a condition such that if I disappear, my family gets, if something happens to Fee, my family gets access. Maybe not immediately, maybe after 6 months, maybe after 1 year. And all these conditions don't need to be visible until I use them. So nobody on chain analyzing the blockchain, coin analytics company and whatnot, they can't just look at the blockchain and go, oh, you know, there's so many keys and we can look at what's going on when people spend. But you know, you don't know until I use it, and I may never need to use the recovery condition. So it's much better privacy.
Christian?
Yeah, so my favorite update, of course, is sick hash no input, but I might be biased because that's actually my own proposal. It is the enabling technology that would allow us to build L2, which is a far simpler and much cleaner way of creating off-chain protocols, such as Lightning, such as multi-party channels, and some really, really nice constructs on top of Bitcoin. It basically is just a proposal that adds some more flexibility into how we sign a transaction, giving us the ability to rewrite transactions after they're signed to other transactions that are compatible or that are whitelisted to be bound to. But of course, the other proposals that are in this bundle, both Schnorr and Taproot, are of course really interesting as well. Especially because Schnorr, for example, allows us to extend the ability to create multi-party channels beyond what's currently possible. So currently there is a limit of 512 bytes in an output script, which limits the number of public keys you can put into one of these output scripts. And so we're currently limited to about 15 channels, which matches perfectly the L2 case, where we actually have a 15 participant channel, and all 15 people need to sign off on changes to this channel itself. And with Schnorr, we can actually boil this down to a single signature being required, which basically just aggregates all of the public keys and aggregates all of the signatures of all the participants. And so we can go beyond that 15 limit. And as a nice side effect, we also hide what we're actually doing here, because, well, this is now just a single sig that is controlling some funds, but in reality, behind the single sig, there is a community of 10 to 15 people that are co-signing about these funds. And with Taproot, of course, we can hide our activity. We can hide the fact that this is a Lightning channel or this is an L2 channel from the rest of the whoever might be watching the blockchain, because it now looks just like a single sig, and and all the advanced scripts are hidden inside of the Taproot commitment. So we get more privacy, we get more scalability when it comes to our channels, and of course we get the efficiency gains that we get from Schnorr.
And just to clarify, the 15 limit, it's not a limit of C-lining, it's a limit of Bitcoin right now. So if you want to have a multi-sig of 20 people, you can do it today. Or not without some novel algorithm.
Scheme. So basically the first round of answers was focused right now on Bitcoin script improvement, we could say. So signature improvement, syntax of the script improvement, introduction of SIG hash no input. I wanted to also ask you about another buzzword that we were pushing a lot some time ago, which is side chains. So we were very excited about side chains just I think 3 years ago, because they were also sold by some of us as potentially altcoins killer. So the idea was, do you want to experiment with something new? It's okay, but don't print new money just to experiment with new infrastructure. Create the infrastructure, but just interoperate with the existing financial asset without bootstrapping the asset from scratch. So that's fine. I remember a tweet by a very faithful Bitcoiner. His name, I think, is Brian Armstrong. And it was a tweet from 2014. It was like, altcoins, I quote from memory, altcoins are a waste of time. We should focus on Bitcoin and side chains. I mean, I agree with Brian. Brian is great. So what is the state of the sidechain idea? Is it still, of course, I mean, Adam, I start with you, and then I will ask also maybe if you have opinions. You, of course, are working with Blockstream on Liquid, so you will be strongly biased on Liquid as a solution. But as a general concept, the idea, I mean, Liquid has a specific set of features. The general concept that if you want to experiment with new feature, instead of printing new scam coins, you should use interoperability with Bitcoin. How is that idea generally going? How is it close or still far? And which are the options on the table?
Yeah, so it's, I mean, there are live sidechains today, but they are, so in the sidechains paper there were two types of sidechain. There was a federated one and a peer-to-peer one. So what's implemented today is the federated one, and one of the reasons for that is that the federated sidechain doesn't need feature changes in Bitcoin itself. So it's possible to implement it with today's script capabilities, and it's has a very clear security model, and it's, you know, it's a good trade-off for some use cases. And so Liquid is used for, you know, it's targeted for providing service to traders who use exchanges, basically. People who use exchanges, particularly people who do complicated trades between different exchanges, like arbitrage and hedging, where they want to move funds between exchanges quickly, or have funds available at exchanges in case they need sort of waiting for a trading opportunity. So what people to do today is not very blockchain-like. You know, they negotiate credit limits, they talk on Skype and haggle about terms, and they take financial risks, which are not very well contractually covered with small startups and individuals, and occasionally they lose money because of it. So, and it's because the transfers are slow. So with Liquid, the transfers can be done in a couple of minutes, and the blocks are reliably every minute, where within the main Bitcoin chain, it's providing different guarantees, so it's a more random process that on average takes 10 minutes per confirmation, but in practice could take half an hour occasionally, or even longer, and you're going to wait for, you know, maybe 6 confirmations for a big trading transaction. So I think the other kind of hesitation about a peer-to-peer sidechain model is it has more exposure to miners, and mining was quite got a bit centralized a few years ago, and I think that's improved over the last year. You know, there are many new competitors, and one of the dominant players has kind of fallen considerably in its influence and market share. So I think that's probably for the better. You know, if mining decentralization is better, peer-to-peer sidechains become safer. Your security model is basically that some threshold, maybe 50% or less of the miners are going to act honestly. So that was one of the impediments to doing a peer-to-peer. And the other thing is more of a technical challenge. It needs additional opcodes in Bitcoin to understand the proof that everything is correct in the sidechain for the claim that they would like to withdraw coins. So there are a few variants of that, but the short-term one is like SPV, so it's just saying that the longest chain in the sidechain seems to say that it's okay to remove funds, and that's really an assertion from the sidechain miners if they were mining it. So with Liquid, we use hardware modules to store keys, and a very carefully chosen small amount of business logic about the security of the peg is understood by the hardware module. So that means it's not entirely protected by software, but also by some hardware. And the peg out funds are enforced to go into offline hardware wallets. So the people that are participating in Liquid at a service provider level are they have their master public key from their hardware wallet, which they put into the configuration, and the hardware module enforces that the peg out goes to that. So that's just an extra kind of security assurance. And I mean, your other question about, will sidechains kill Ethereum or Tron or EOS, or, I mean, there are dozens of them these days.
Or Monero, I mean, a project I love, but if
Yeah.
you can do a Bitcoin Monero sidechain, why not? I mean,
Right.
can we tell people just create your Bitcoin sidechain with Monero technology, or we still can't?
I think we can. I mean, the source code for Liquid, there's an open source project called Elements Project, which has the source code, and there are some companies, I think Commerce Block has worked with it, and other companies are using it, so you can use it to start your own chain or make changes. You do need to operate a federation today because it's not fully peer-to-peer, but I think, I think somebody said on a panel yesterday that it doesn't seem constructive, and this was my reaction for altcoins to, keep trying to repeat and make new coins because it's a form of dilution, and they generally have not proven to have long life, because there's a constant stream of new ones with new marketing budgets and the old ones run out. So I think it's much more interesting to focus on delivering value on top of Bitcoin. We have Bitcoin, it works. It's kind of analogy people use is the internet and TCP/IP. Everybody built on TCP/IP. Video streaming, web traffic, email traffic, all kinds of applications, all based on one protocol. It doesn't help progress to have dozens of competing protocols that don't really have meaningful differences at the base level. So the base level here is a very deep liquid electronic cash, which I think is Bitcoin. So I think it's far more likely that that sidechains do eventually win out over altcoins as a way to do innovation, but probably the downfall of the altcoins and different smart contracting platforms will be themselves, because they're competing against themselves. So, EOS and Tron, and I don't even know all the names of them these days, but many of them have quite large budgets, and they're using their marketing to search for visibility, basically.
So unless you guys have a contribution to the sidechain topic, I will ask you do.
So just a quick note. I've just been asked yesterday again whether Lightning is actually a sidechain, and it probably depends a bit on the perspective you take on this.
It's an altcoin, right?
It definitely is, yes. Actually, an altcoin is our latest release name. And it probably depends on which direction you come from, right? If you come from the experimentation side of viewpoint, then probably isn't a sidechain, because we don't use a blockchain, we don't use it to experiment on innovations on the base blockchain. But if, like you did initially, come from the Bitcoin being the denomination point of view, that you don't need to create your own currency to start experimenting, then we're pretty much a sidechain, because we are denominated in Bitcoin. We build on top of the Bitcoin blockchain, and we try to extend it that way. So I guess it depends a bit, and thank you very much for the person who asked me yesterday about this very philosophical question about whether Lightning is a sidechain.
I heard a philosophical argument that a single Lightning channel is a permissionless sidechain of two people, and they are all interoperable.
That's possible, yes. So you see that we can probably go on about discussing this, and you will probably hate me for bringing up Lightning in every single topic, but hey, I'm the Lightning guy, right?
I thought sidechains implied there's blocks and there's no blocks in Lightning.
Yeah, that depends on which viewpoint you take, right? If you take the currency viewpoint, where we trade Lightning and we trade Bitcoin, and we denominate everything in Bitcoin, then we are a sidechain. If you come from the technology aspect and talk about a blockchain being used to experiment for features that we might backport into Bitcoin, then we're definitely not a sidechain.
Basically, we could abstract the side system terminology to indicate any system not using the Bitcoin blockchain to transact Bitcoin. In theory, correct me if I'm wrong, but Liquid could not use blocks in theory, could maybe sign any single transaction to avoid double spending. So the fact you use blocks is mostly interoperability and reuse of codes and standards, right?
So an exchange moving funds from one account to another is a sidechain?
That's a good question. An exchange with a very strong HMS structure, is that a sidechain? I don't know.
So
okay, we're going.
It's probably also worth mentioning that sidechains are far more flexible than layer 2 protocols, because you can actually change the fundamentals of the blockchain itself. And like you said, you could do away with the blockchain altogether, whereas Lightning will always have to represent all of its state as Bitcoin transactions. So that's the limiting factor for Lightning, for example.
So starting from Lawrence this time, yesterday during the key management panel and demos, kind of a specific mantra emerged about the fact that you have to save this big number, this secret key that was explained like, you know a number, as far as you know this number, you will move Bitcoin. So this model is very simple conceptually. You know a secret and you move Bitcoin. But with all the evolution we are talking about, for example, let's assume a Schnorr taproot very long script in which you will expose to the blockchain only one part of the script if needed. In that case, basically, and that extends a little bit to Lightning as well, again, because you have, for example, partial state updates in channels. So with these evolutions, there are a lot of things that are off-chain and that are not just included in your key. So do you think that key management, for example, a very complex version of Green with taproot scripts, you don't have just to save the mnemonic and the deterministic keys, you have to save the script as well. Is that going to change the way we will have to teach key management and hardware wallets will have to function, or it's just basically about the same, you can just focus? I mean, is your mnemonic enough to manage your funds in this very advanced off-chain structure?
I think so. I was planning to do everything as much as possible deterministic, so that you would never need to back up anything more than your seed, your mnemonic words, or backup phrase, however you want to call it. There's some interesting things that you can do once you have taproot and whatnot. So I was thinking, as you were mentioning this, I thought you could have situations where you have some strong hardware with a key that you never had, you don't have a backup of, you only have the public key of, but the scripts you use have a conditions that allows you to recover. So you could have this on a phone, for example, and then if you ever lose the phone, you use the other conditions to recover. And the other conditions could be, family and friends, or it could be, some keys that you have at home or in offices or whatever. And this sort of thing allows you to do possibly even more secure hardware, because if you're generating, you can generate a key inside the hardware with the external entropy, prove that the entropy is used within the key, and yet not ever have access to the key itself, such that it cannot be extracted and it cannot be used. So I think once we have Taproot, we can do things that we didn't even think much of.
Okay, take my money. But that's not so easy for partial state updates in channel, right? In that case, you cannot just rely on the mnemonic. You have to save constantly other kind of toxic wastes.
Yeah. So one of the current issues we have with the Lightning Network is that we can't really do good backups and restore. The restore being the hard step, because if you restore a Lightning wallet and it has gone out of date because you have done some trades after backing up, you might end up with a state that is not the latest one, and it's really hard for the blockchain to recognize that yes, this old state is being broadcast because it doesn't know better, or maybe he's trying to cheat you out of your money, right? So backups in Lightning are hard, and that comes from the fact that that we have this interactive protocol in which two parties discuss, and if I lose some signatures from you and I'm only left with some old signatures, I can't do anything better than use this old state, right? So with this new flexibility that we get with Taproot, it's flexibility, but we have to be careful about how we use it. And the designers of Taproot and Schnorr are really hell-bent on making it as secure as possible, without giving up on the flexibility side. But at some point, it's a trade-off, right? So I think the trade-off we are currently looking into is quite nice, and will allow us to do some really cool stuff. But yeah, it definitely needs some serious consideration, especially if you have these multi-party protocols where multiple parties exchange signatures and exchange public keys, and you might act strategically and sort of try to cancel out your opponent's key, for example. And so there are mechanisms in there that are being used in the design of these proposals that should make it harder for this to happen, but it's flexibility we need, right?
So for all the panelists, starting from Adam, activation. Assuming we are talking about this bundle of Schnorr, Signature, Taproot, and Sigash no input, just as a minimum set, maybe something else. Do we use BIP 8, BIP 9? So yesterday we discussed about the history of Segwit. Segwit was not a controversial, was not a technically controversial improvement. All the technical people were hacking Segwit without age hack. We're okay with Segwit, but then they used a mechanism to signal readiness by miners, and miners started to leverage that mechanism in order to vote instead of signal. So that created a political drama that lasted for a while. Are we going to, in your opinion, to expect the same, or are there alternatives that are alternatives to that kind of signaling mechanism being discussed for this new improvement, or not?
I mean, there was the original activation mechanism was BIP 9, and there's an alternative that somebody had proposed called BIP 8, and there's just one small difference, which is there's a period for the activation level to reach its threshold. And with BIP 8, if it doesn't reach the threshold, it activates anyway at a fixed date. So it kind of gives a flexible way for miners to signal that they have upgraded and they're ready. But at a long time, I think like a year, it will activate regardless, kind of thing. So that's one alternative that's been considered. I haven't been involved in the discussions, but maybe there are some other alternatives. I mean, one very simple one that's been used in the distant past, I think P2SH was done with a flag day.
Proof of Gavin.
Yeah, I mean, a flag day, like this activates here. That's not as flexible, and maybe has its risks if you wanted to back out or something.
Yeah, I mean, I think that the idea of having miner signaling and then activating anyway after a certain date is great, because it allows to go as fast as you can if everyone is on board and activating. Otherwise, it will have to take longer, but it will happen anyway. So
what about proof of hash? Can we just use hash to signal readiness like in WASP?
Well, yes. I mean, I was a supporter of USF, but I don't know if it's going to be like that or not. I thought Schnorr wasn't controversial, but ultimately took a bit. Now I don't think. Sorry, I said Schnorr. I meant Segwit. I don't think Schnorr and Taproot are controversial, but we'll see. Because there's a privacy component that I'm sure some people are not going to like. And so I'm afraid that there's going to be some pushback from people that are not privacy happy.
I mean, I think it'll be interesting to see if anybody is willing to be vocal about being anti-privacy, because in previous discussions, you know, if there was a scaling discussion, there are reasonable trade-offs to argue about. It's not necessarily black and white, within reasonable bounds, right? Obviously, huge or unlimited is just doesn't make computer science sense anymore. But with privacy, when there have been discussions with user community, I think a few years ago, Trace Mayer asked the question of what are the primary features of Bitcoin that people value? You know, if it lost this feature, would you stop using it? Or if it didn't have this feature, would you not make a transaction or something like that? And it seemed like for privacy, you know, almost everybody was in favor of privacy on the user side. And I mean, exchanges are just providing service to users. So if they say, oh, we don't take transactions that are private, users will just switch service provider ultimately. So it's very unpopular for people to say they don't like privacy. So it would be interesting to push them to see if they were willing to do that.
Bitcoin without censorship resistant is not very useful. It's like a worse version of PayPal, less efficient, more costly, slow, stupid. With censorship resistant, you know, it really makes sense. And this would massively improve the censorship resistant, because you don't know, and if you don't know, there's less to censor. So yeah.
Yeah, I mean, we probably aren't as much in a political scenario as we were with the SegWit activation, but with most of the people that were shouting and screaming, having gone do their own thing, I don't see that same level of discussion and toxicity in the community like we did with SegWit. We don't see people claiming that now suddenly all the money that you put on SegWit is basically anyone can spend, or that this is overly complicated, or all of these nice arguments. It's quite the contrary, right? SegWit bought us the ability to create some really nice and deep changes without having to hard fork anymore, and so we now can engineer these really clean and precise and minimally changes to the Bitcoin protocol in a very targeted way without having to carry around the baggage from previous generations of the protocol. So I think this is uncontroversial. Unlike maybe SegWit, I hear far less opposition to this bundle of upgrades, and I'm pretty hopeful that we can get this done quite quickly. Whether that be a flag day, whether that be signaling followed by default no, or signaling followed by default yes, I think either would work. So I'm pretty positive.
I think if you want to find something controversial, maybe you want to touch on neutrino. Not
don't go looking for those.
Coin analytics, the other one.
Which is anyway, I mean, not consensus change, so it could be more. Well,
potentially
could be.
Potentially
right.
Could be backed
that
by
could
a
be
soft fork, which helps
to
with
to force the commitments of the filters in. Well, maybe even Sigashno input had some controversy about the punishment model against the not punishment model. Among some Lightning developers, I've seen some discussion about that, right?
So I think that, so just for context, Lightning currently uses punishments. So if you misbehave, you lose all of your funds, whereas L2 is just override based, where basically if you publish an old state, I will just override whatever effect you had without stealing the entirety of your funds, but you will still have to pay fees for your failed attempt. I don't think that this is a criticism of Zcash input itself. It's more of a criticism of L2, and a fair one at that. But I don't know how deep I should go into L2. But I mean, the fear is often that removing punishments would make it basically free. That for you to attempt to cheat. And so if you don't have any skin in the game, you can just try to recover your funds. But it's not free because you have fees. You might not die from the first attempt of cheating or the first mistake you make. I mean, it happened to me that I published an old state by mistake, and suddenly I lost my money. Everybody loves punishing cheaters as long as it's not them cheating. So I often compare it to a death by 1,000 cuts compared to a beheading. Even a death by 1,000 cuts will kill you eventually. It's just a bit more forgiving. And the current limit that we have in Lightning is that you have to have 1% in reserves. You can never go below. So the most you can lose, if you're a strategic player, the most you can lose is 1% of the channel capacity, which is less than the transaction fees currently for many, many channels. So L2 would actually punish you more for cheating, not less. But going back to SIG hash no input, this is not a criticism about SIG hash no input. We are basically discussing on how to make SIG hash no input harder to accidentally misuse. But I think the core concept of SIG hash no input is pretty much established, and it's protocols that we build on top that might need refinement, and where the discussions are at.
So, Ton, I think we have time for maybe a couple of questions from the public. If you have some, use the mic there. Thank you.
Oh, I didn't get to talk about Lightning improvements, but this being Bitcoin base layer improvement, you could go on for hours.
You can twist an answer to, I mean, thank you for your answer to your question, but...
Okay, so... Okay, 1, 2. Hello, hello, hello. It's fine? Hello, hello. Now? Better? Okay. So I have 3 questions because we have 3 panelists. So the first one is on green address. If you have a multi-sig, 2 of 2 or 2 of 3, and one participant is a server, can you see all of the transaction of the green wallet in a privacy perspective? This is the first question. Would you? Should I ask all 3? So.
It's clear, we ask all and then we answer. If it's not clear.
No, you want me to answer or wait?
Okay, thank you. The second one is what are the trade-offs of SIG hash no input? So what are the trade-offs or drawbacks? And the third one is what are the secure mechanisms of possible secure mechanism of side chains? So I think something like merge mining exists or something. What is reasonable for this kind of side chains maybe?
Okay, let's go with the first about the multi-sig.
Right. So yeah, the green apps are server-based, and when you create your own seed, your mnemonic, you generate the XPub, and that gets sent to the server. So the server does know about all your transactions because it needs to cosign them whenever you have a transaction. Now, that being said, we have been looking at blind cosigning and enforcing some of the rules like Google Authenticator or threshold limits and so on and so forth in a blind way with some sort of zero knowledge proof. It's still fairly far away, but in a way it's also getting closer because I think we're going to try some of these things on Liquid, where the server already doesn't know your blinding keys. So in Liquid, all transaction amounts and assets are potentially blinded, so that if you're watching on the blockchain, you don't see the amount or what is being sent. And when we integrated, or when we started integrating Liquid in Green, it was one of the design choices. Like the server should know nothing about this as much as possible. It still knows about the XPubs, unfortunately, at the moment, but it doesn't know about the amounts. It doesn't know about the asset, and we want to still offer things like threshold limits, so that you can ask the server, don't ask me for 2-factor if I'm spending below this amount, without you knowing what's the amount below and what I'm spending right now. the server won't know either. So that's one of the things we're going to work on.
Yeah, so the second question was about trade-offs of Zcash no input, and just for context, Zcash no input basically removes the reference to the previous output that you are spending when signing a transaction. So let's say you have like 5 different transactions, all have the same amount, all have the same script, and now you want to have one transaction that spends one of these. You can do what I call rebinding, which is basically the reference inside of the transaction, which tells you where the funds come from that you are now reassigning. You can basically remove that and replace it with any of these 5 compatible ones, without having to resign. That is. So that is the core functionality that we rely on with L2, because, well, we have this chain of updates that we'd like to rebind to. But it's also the main weakness that is being pointed out, is that, well, if we have 5 of them, and I can change the output that I'm claiming with the transaction by just rewriting the transaction slightly, I could replay this transaction multiple times for all 5 of them, right? So that's definitely an issue. The compatibility between these transactions, the outputs being spent, and the spending transaction is now done through the compatibility of the script. So if all of these have pub key A, and here I have a signature from pub key A, then I can do this rebinding. But this is the functionality we need, and we're very clear about you should only use Zcash no input if you make use of this functionality, otherwise you should not. And there's been talks about, do we want to have some form of opt-in where we can signal, hey, this is, by the way, you can sign this with Zcash no input if you need to, otherwise please don't. And there's different proposals about that, but again, the core functionality that we want to introduce is also one of the things that we need to guard against, so to speak. But my usual argument against these kinds of bike shedding is that, hey, we have Zcash none, which doesn't sign anything about a signature, and everybody is happy with Zcash none. So why are we trying to make it really complicated for this small malleability rather than?
Yeah, so you can today create transaction that anybody can spend. Like if I see it on the blockchain, I can take it and spend it. And everyone else seeing that can also do that. And ultimately, the miner can do that, and just before including, they'll swap it with theirs and take the money. So it's possible today, and this is just...
Yeah, it's basically just discussing about safeguards that we can put in place for normal users that are not protocol developers to guard against unwanted rebinding of their transactions.
So did I understand it correctly that only the person who signs this Zcash no input can change with the signature of itself, of himself?
Yes. So
no other party can participate and change something. Yeah.
So when signing, you basically say, hey, I'm signing this part, and this part, and I'm skipping this part. And the way you signal that is by saying by appending the Zcash flag. And if you switch the Zcash flag, the signature will not verify anymore. So at the time you're signing, you basically decide, do I want to sign this with Zcash no input? Do I want to sign this with Zcash none, or do I want to just sign everything in the transaction like what's default currently? Yes.
So a little bit of context of the question to Adam. We discussed the security model of side chains, for example, federated or peer-to-peer with hash escrow, about two-way peg, so which is the security to send Bitcoin there and take Bitcoin out. But there is another aspect of security, which is anti-double spending. So in a federation model, of course, the security is federation, but in a peer-to-peer model of a side chain, when you have, for example, an hash rate escrow, what is the security model for anti-double spending? Because, for example, the question mentioned merge mining, but there is some controversy about merge mining, for example, from Peter Todd and other developers. So what are your thoughts about that?
Yeah, I mean, so one issue is mining centralization, because with merge mining, you could, in principle, mine Bitcoin honestly, like make a profit by collecting Bitcoin rewards, while merge mining sidechains either honestly or dishonestly. So in other words, you still get paid most of the reward because the Bitcoin reward is large, and the Bitcoin fees, while you lose out on the sidechain related fees. So in the sidechain that's merged mined, the model of what the reward is for the miner is they collect additional fees on the sidechain. And the argument is that, well, you know, there's no reward on the sidechain. And this is true, but it's sort of similar to Bitcoin in the long term. So in the long term, Bitcoin's subsidy is halving every 4 years. So you get, with the merge mine sidechain, a kind of preview of the very far future of Bitcoin, where the security is the fees, and that's your incentive. So the argument is really, like, is it incentive compatible? So I think, yes, it's just a preview of the further future. So many things about sidechains have been previews about the future, you know. So it's had segregated witness has been in Liquid and Elements before it, or a malleability fix very similar to SegWit was in there before it was in Bitcoin. Today there is confidential transactions in the sidechain, which is something a lot of people are interested to eventually see in Bitcoin, maybe with some more space efficiency improvements. There's one additional kind of incentive problem, which is that even if the fees on Bitcoin and the sidechain are the same, somebody could try to, so that there's a similar incentive to mine honestly on both, somebody could try to take all of the coins in the sidechain. And there are a few countermeasures that people have talked about. Paul Stortz has a model called drive chains, which has a team working on. And in that model, you make a very slow withdrawal, so maybe a few months. And the idea is that if somebody did try to take, if a group of over 50% of miners did try to take the funds on the sidechain, everybody would notice because this is all publicly visible, and would try to stop it in some way, make a software change or something. So I think the really long-term answer, which can make full security for the sidechain model, is something snark or bulletproof related. So today you can make bulletproofs that are proofs of execution correctness, that this chain had this value had this calculation done on it, and we know the output without rerunning the calculation. So you make a proof of execution. So that could be, if there was enough computational resources, the proof of execution could be done for the whole validation of a sidechain. And that's actually the original description of the concept of a two-way sidechain was with that context, that that was a far future possibility. The problem is today they're very expensive.
Thank you very much. End of the panel. Thank you very much to Adam, Lawrence, and Christian. So, before switching to the second panel, which is mining, we will have a third attempt to basically overcome the poltergeist effect that we had yesterday with Nadav's presentation about charge, and we should be ready to go today. So it will be 25 minutes, a little bit more. Then we will start with the panel on mining and the demos on mining. We will try to limit the pauses during the morning and to maximize the pauses during the afternoon when you are more tired. So let's try to check the screen.